you a code. Stop stealing my Tristan.
All right, that would stop stealing my Tristan. Okay, so I'm gonna pass around our European candy. There's two kinds. Just take one. Shh, Michael, Cole. Take one, pass it on. The first kind are Maltesers. They're kind of like Whoppers.
But they're way better.
But they're way better apparently. And then this is called Milky Bar. And it's kind of, I think it's just like white chocolate, basically. Ethan, I don't see anything about nuts on them, so.
Yeah.
If you die, it's not her fault.
At your own risk, and I have 4 EpiPens accessible. So anyway, those are mine. 5 for counting yours.
For each limb.
So yeah, really, 1 for each limb. There you go. And
Like
if
the
we use
Macarena.
yours, where do we stick the 5th one?
Good one.
I don't want to know. Where's the 5th one?
Oh,
go?
no.
And that.
Wait, you stick the EpiPen if you like.
Sorry.
Thigh.
I didn't even
Right,
know that.
right here. You don't know how to use your own EpiPen?
I know how. I just didn't know.
So you obviously know how
Wait,
to
can I
do
take
that.
one of each?
But, let's just do one until we're sure everybody has what they want, and then.
There
Yeah, so like when mine I had one that it was really expired, so we took it apart just to see how it worked, and I wasn't very smart, and I should have been wearing goggles, but I took it apart just to see how it worked, and
Oh,
somehow I
there.
activated the spring, and the needle, which is like a nail in that thing, by the way, it's not a little needle because it's meant to go through clothes. It's like a big needle.
It shot
And,
up and stuck in the ceiling.
It did. It wasn't crazy. Okay.
Well, it's expired.
An EpiPen that I had that was like super duper expired.
Oh, that one.
I was just curious to see how it would work, so we took it apart to
You
see
took it
the
apart.
mechanism. I took it apart. I should have been wearing.
And it went up right there.
Yeah, it
right
left
by
a
that
little.
pillar.
It left a hole in the kitchen
It's
ceiling
tiny.
where it jabbed the ceiling. It was,
Then it stuck in there like an and just stood there.
and well, then it fell.
Their fault?
Yeah, it took a
So you
minute.
had to go up there and get it.
No, and it made a good hole. So anyway,
One shot.
enough about EpiPens. All right, so we're gonna start with some hypotheses.
Wow.
All right. First
I
question.
like it.
First hypothesis is an easy one. What will happen if I blow up this balloon right here like this, just sitting here?
It'll be.
It'll get big. Anybody disagree? Ta-da! Are we excited?
Wow.
Okay, now, what will happen
If you let it
if,
go,
no,
it's
shh. What will happen if I hold it right here and blow it?
it like conform to the shape of the beaker.
It will conform to the shape of the beaker. Does anybody agree or disagree?
Yeah, it'll mostly, maybe around the corners. of the
Mostly.
round.
Okay, ready?
Oh.
Oh my god.
Whoop. Let's try that one more time. Here.
I didn't do anything.
That's no problem. Okay.
Well, you make a little seal.
Okay. Now hang on. Try one more thing. Now what will happen if I blow the balloon up?
It'll
I think there's.
shape around. It'll push the.
I
It'll
think you need
squish
more
the-
straws.
Think I
it'll
need more
squish the-
straws?
We try to blow up the beaker.
Take 'em. What?
Whoa!
Whoa!
Oh yeah.
I thought you need more than one straw. In
What
this.
happens
So
if you
What
put
happened?
a lot of pressure into the balloon? Like you put like a lot of air into it. Like will the beaker eventually like not be able to hold it?
Yeah, but I don't think
actually the
balloons have
balloon would probably rip first because it's so much weaker. But if they were of, comparable strength,
If the balloon was
it could
titanium.
probably. Yeah, sure.
First
So what happened? Why does this work?
Because the straw stops it from getting out.
The straw stops it, like the air, like it makes it.
It doesn't stop the
Well, it doesn't stop the air,
What's
but
it
like
do?
straps. I don't know.
So why doesn't this work? Thinking in terms of air pressure, why can't I blow it into there? Why doesn't it work?
Because the air is
Six
stuck in the
seconds.
bottom.
Because the air is trapped in the, what is this called?
Beaker. Graduate similar.
No.
Oh,
Oh,
I get it now.
Oh.
Measuring
What
glass.
is it, little ears? What is it? I'm sorry. What is it?
It has a really flask.
It's an Erlenmeyer flask. Yeah. Okay. Erlenmeyer flask. So why doesn't it work? Why does it work with the straw, but not without the straw? What difference does the straw make?
It allows the air to blow out.
It allows the air to flow out.
Wow.
So here's what you have to remember, that this balloon right now at rest what it wants to do is, and always wants to equalize the air pressure outside and inside of that membrane, okay? Always wants it to be the same. That's why when you blow it up, you have to tie it, otherwise it's gonna come out, right? Because the pressure inside is much greater than the pressure outside. What is with the Triscuits?
You stole. I'm gonna took one. There's like 10.
I got one from him.
Okay, so when you put the balloon in the flask and attempt to blow it up, and it has nowhere, the air inside the flask has nowhere to go. It's in a closed system.
It's really good.
It can only expand but so much, right? Before it has put all of the air in the flask under as much pressure as it can possibly put it, right? And then when you put the straw in, it gives room for that air to flow. So the goal is always to equalize pressure, and it always flows from high to low, which is what you saw with the siphon, right? Fluids always go from high pressure to low pressure. And that would include both air and water. Right. Right. Okay.
Let's get right.
So, yeah. All right, so let's screen share for a minute. Did anybody, by the way, did anybody see the, what? No, don't do that. Did anybody see the videos that I linked to the, oh, there it is. The videos that I linked to the forum group and the pictures with the rock formations and stuff? Yeah, I've got really good video of that I'll show you guys. It was really, really neat because Jason took his drone and got amazing.
Oh, I got some interesting stuff on the beach.
Well, yeah, we're not going to talk about
Yeah.
certain people's beach graffiti.
What?
So, certain people drew in the
What?
sand.
Wait.
Drew, did you and I what?
He is Jason's son. is the
Drew
thing.
drew a pee-pee?
Yeah, I wasn't going to go there, but.
Talking like
Whoa, was
60
it really big
feet long.
Okay. All right, you're being recorded. Okay, so.
No, let's get wrong.
Yeah, all right, there we go. All right, so let's go ahead and look at our notes and see if we can work our way through today's lesson. So did you guys, I haven't graded anything yet because I have to wait till after this class is done to make it worth my time. Otherwise, I have to get in and get out and get in and get
My
out.
mom was spiraling so hard because she's like, "You got 76? What do you mean? No, no." She got really mad at me. I was like,
She knows that I have to go over them all, right? Like,
yeah, she knew that, but she was like, "But you got back from vacation. She should have graded them." She
oh,
was like,
no. I didn't, you know what? I was going to, but the problem is, unless I keep like a very detailed list, I can't remember because there were multiple assignments for you guys, right? And 20 of you. So I can't remember whose I graded and whose I didn't, and I end up looking at them 2 and 3 times, and it's a waste of time. So I'm gonna sit down at one time, do them all. You know,
Well,
it's just
then I'm
easier.
really glad I didn't do it like 2 weeks ago.
Oh yeah, there you
I
go.
did it last night at like 1:30.
All right.
I did do it all. Like
You know,
2
have you
weeks
met
ago.
Cole? This is Cole.
I didn't
Cole
even
turns
know.
in his 10-page college research papers 30 minutes before they're due.
Oh, yeah.
Yeah.
45, alright.
Mhm.
And he started debate last night. He had to write an entire case.
Because he had to write the 10-page research paper. Mm-hmm.
I need at least 4. No.
It took him 3 days,
Ooh.
but it was brutal. It was very brutal.
It had
Fun.
some stuff.
On the topic,
Good stuff.
that's my little segue to this topic. On the topic of pressure,
Stop saying topic.
Cole,
Feeling under
Cole, would you
pressure.
please explain, based on your research paper, which was history, and you could pick anything, and you talked about Pompeii. How did the, okay, wait, who knows how the people in Pompeii died, or who has
Not
heard?
everybody, but a lot of them.
Do you know?
So the ash basically covered them and fossilized them like really fast. And
Okay.
it just suffocated.
Suffocated. How about anything different?
Yeah, but it's really funny because you can go there
Mhm.
and you can see holes shaped like humans.
Yeah.
Yeah, it's hilarious.
All right, so wait. So actually, that assumption that they were
It's not
crushed,
completely wrong.
that they,
Somebody
yeah,
died by
that assumption that all of them or most of them were crushed by debris or suffocated with the ash actually was recently disproven with a research
Well, not
project.
completely.
No, but
It's not saying that
it
nobody
supported
died
their
that- it's not saying
hypothesis.
that
So
nobody died that
not
way. It's just
entirely
somebody said
disproven,
that.
but it's about pressure. So would you explain?
When the volcano erupted, it sent these things through the town or to the town.
Pyroclastic density surges
And they're basically just really hot magma floating through the streets.
and air from the
they
magma
got
is super hot.
temperatures as high as like 500 degrees Celsius, which is a lot higher in Fahrenheit.
Ridiculous.
Go.
I
5
think it was 932
Oh,
or
too long.
something.
Something like that.
Yeah.
Insane.
But
So what happened? Wait a minute, listen, this is cool.
what they found through looking through some skull fragments of people was that it was possible that the heat was so intense that it basically
skull melts.
vaporized all of their bodily fluids and soft tissues, and that pressure and I guess you could say
And that
steam for
kills
lack of better words
Yeah.
blew their heads open.
Oh,
wow.
That is how-
I'm not saying everybody died like that. I'm sure people died from debris and suffocation. but
Everyone died
a
that
lot of
way.
people from the
Yep.
first few
Like,
seconds died.
So once again, pressure wants to equalize, right? And it will always flow from high pressure to low pressure. So in the research that Cole read, and I read it all over too, because some of it got really sciencey and it was talking about equipment and stuff that he hadn't heard of or whatever. But in essence, it was so hot that when the pyroclastic density surge, which is essentially all of the hot everything coming from the volcano, the hot ash, it doesn't even necessarily have to be magma itself, it's the air around the magma that's heated, was so hot that instantaneously they died, instantaneously, because their body, the soft tissues around their bones, which are not protected by another bone, literally vaporized, gone. And they did not find evidence.
At that moment, they're dead.
Right.
The skull did not kill them.
But
In your
because your
because
brain
skull protects your
is
brain,
in-
your brain vaporized and
it's
it needed to get out
enclosed.
somehow, so the
Pressure's-
pressure just went,
pressure's got to flow from high to low.
and all
So-
the fluids in there too.
Yep.
So your
And
brain
they
just
found
really
this
dead.
to
Those
be-
ones are already dead.
They found evidence for this because with skull
Inside of the skull
fragments,
they saw what looks like blood residue all over the inside of the walls, which they thought was kind of weird, and they went through and they found out it was blood because explosions.
That's one
Mhm.
sick way to die.
They
Looks like
found-
it's cool.
they
I
found,
can't believe that was-
they
That's
were
the way to
looking
go.
for
I can't feel things.
heme iron, iron from blood,
Proteins.
and they look for proteins which they did not expect to find because those should have been obliterated at that temperature, and they were.
So
But
it's on
what-
the elements that made it.
Yeah, so they could prove that the temperatures were high enough that the reason they found iron, which is not present in any of the other materials inside their skulls, is from crazy, huh? All right.
So it was just so hot around the lava.
Mhm.
It wasn't even the lava.
What do you need? The badge?
No, it was
Okay.
just the heat.
What do you want,
The
honey?
balloon.
No. All right, so let's look at our notes, all right? All right, so we are in chapter 13.1, lesson 12, fluid pressure. All right, we just did all this. So pressure is the result of what? What's it say?
The result of force distributed over an area.
Good. All right, Ivy, what's the next one say? Do you have it?
I don't have it.
Oh,
A
who
one.
has it? Number 1. You got it, Michael?
To calculate pressure, divide the force by the area over which the force acts.
Right. Okay, so pressure equals force over area.
I mean, flipped to this.
I love how y'all are like sitting down, your notes are out. Yeah. What? Okay, just go get some, get a carpet cleaner and a rag or whatever, and I'll deal with it later. I don't know, look for something in there. Okay, hold on. Cole, can you help him? Just find him a carpet cleaner real quick. And a rag.
Uh-oh.
It's all right. We'll fix it. No biggie. Exactly. It doesn't matter who did it. It's being fixed. We got it.
It's for gothic reasons.
No. All right, so pressure is measured as newtons divided by meters squared, right? What's the SI unit for pressure?
A Pascal.
Pascal. Very good. Yeah, it's Pascal. Yep. Just like Easter Pascal. Thank you, Cole.
Pascal, just like the
Pascal,
wizard from
Mm-hmm.
Yeah.
The lizard.
Pascal.
Actually, it's a chameleon.
Actually,
Legit, it's a
actually,
lizard.
Or a lizard.
No, they're not.
it's just Nate Foster and Melopine. He just turned into your dad again.
Mansplaining lizards.
So you got pressure, which is force over area, and we can measure that in pascals. All right, so let's look at the diagram there under letter B. It says pressure in fluids. A fluid is a substance that flows, assumes the shape of its container. Both liquids and gases assume the shape of their containers and are thus considered fluids. All right, so look at the graphic there. All right, we've got a solid in a, let's pretend they're beakers, okay? And then a liquid, and then a gas.
What does it mean by free surface?
Okay, that just means
It
that
has a surface area.
it has
So
an
the
actual
solid-
surface.
The solid is also free surface.
It's not free because it keeps the shape. So solids are always going to hold their shape and always going to have a fixed volume. So fixed shape and a fixed volume. So I want you to think about, you have a bucket of sand, okay? And you pour the sand into a big curvy vase. Is the solid keeping its shape?
Yes.
How?
Because the solid are the tiny rocks,
Right. The solid are the itty bitty grains of the sand.
not the combination of all.
Not the combination, but it acts like a fluid when it pours when they're all little like that, but it's still a solid, right? Okay, so liquid takes the shape of its container, has a free surface, that means it actually has a visible surface that moves about, and a fixed volume. Okay, so the fixed volume for all of these things, it's assuming, and the fixed shape and everything, it's assuming that this is at the same conditions, okay, without changing the conditions. So let's imagine for a second that this beaker that the liquid is in is not a beaker, but it's a pot with one of those tops, like a pressure cooker that snaps down, and we stick it on a burner and we turn it on. Is it going to keep its volume? The liquid.
The liquid?
Mhm.
No. If you steam it,
If you heat it up, what's going to happen?
it's
Oil.
gonna.
Evaporate.
If you heat it up long enough, it'll turn into gas.
Right, there you go. Right, okay. And how about if you freeze
So
it?
it's no. If you freeze it,
So it'll fix its shape into.
But will it fix its volume?
No. no, it
No.
actually grows.
It expands. Okay, so
Like
when
water
water,
cracks,
depending on
freeze.
the liquid, if we are assuming the liquid is water, then it will expand. Not all liquids are going to do that, but a lot of them will. So with water, when you put water in a freezer, it crystallizes, right? And when it crystallizes, that structure that it builds actually causes the molecules to spread out from one another to build the nice, neat structure. So when that happens, it actually gets bigger. That's why you can't put a soda can in a freezer. Anybody ever had a soda can in a freezer or outside? What's it do? Oh yeah, it's awful. Sometimes you do that by accident, like you buy a can of Coke or a whole 12-pack and they're warm. You're like, I just want one now. I'll put it in the freezer for 20 minutes. And then you forget it. And then you open the freezer and it's like, you know,
Everywhere.
everywhere.
Arima, why did you do that? This is the 4th time this month.
Wow.
There you go.
Wow.
And Aunt Lily was talking.
One time I was on vacation and we were staying in a hotel. Apparently they forgot to clean out the freezer because there was a soda can that exploded. No,
Nice.
wait. No, it was my great aunt who we were staying with that had put it in the freezer and then
Oh.
it exploded and she had to
Kaboom.
clean it up because we weren't cleaning it up.
That's a mess. All right, so think about the gas for a second. All right, Cole just gave us a great example of this, but say you have a gas and it's not in a beaker. Say it's in a container and it can't escape,
When did I do that?
and you heat it up. What's going to happen to it?
Why are you looking at me?
I don't know.
What's going to happen to it? If you put a gas in a container,
Will blow up.
it'll blow up, right?
Oh,
So-
okay, now I see.
This is basically what happens. Like, this is how a lot of bombs function, right? Like, you seal something up entirely, you make it so that there's a charge, so it heats everything instantaneously, and it expands the air in there, and then what? Yeah. Okay, what about if we took a bottle of air, and just regular air, and we put the top on as tight as we could, and or even not the bottle, what if we did it with this? What if we took this, blew it up, tied it up, and stuck it in the freezer? What do you expect to see?
Can we do that?
Sure.
Can we do that?
What would we expect to see?
It
It
would shrivel up.
It would shrivel up?
Wait, I just know. So I had a football and I pumped it up. It was a really hot day, and it just exploded.
It just exploded? Awesome. So I'll measure this in a second, and we'll put it. I'll measure the. Actually, let me do that. You have.
let it go, let it go.
Okay, I'll tell you.
cards.
No, let go.
You really
I'm gonna measure
Yeah.
it.
Let it go. Let it go.
I'm gonna measure it right around the center, and I'm gonna put lines on it. Right?
So is the difference between the cards just the packaging and then
All
like
right.
So there's different cards if you get.
Why did you ask?
Yes, there we go.
And I was hoping for a short
Michael
answer.
loves
Yeah,
his
that's-
cards. He's a card
You
master.
can get different codes on the cards and stuff.
Oh, cool.
So these are super slick.
So I'm gonna measure through
Is that for
here.
like a math?
All right. So around the center, through there, we have, oops, I didn't flip it. I'm measuring
Oh,
inches.
dear.
I'm measuring centimeters.
No, you did not.
No, really.
Okay, good. I was joking.
It's like nothing, Hunter.
Here we go.
Dragon feature. I hear
I
you
know, I'm
sound
fighting with it, aren't I? All right, round and round and round. Here we go. Okay, so this is
good. Yeah.
42 centimeters. I'm gonna mark it here too, so that we line it up perfectly. 42 centimeters, okay? And I will put it in the freezer right now. Don't let me forget. We'll take it out when we're done talking. Honey, put it in the freezer. How much do you think it will shrink?
How much do you think we'll forget?
A negative 10.
2.5.
2.5 centimeters?
Wait, no, I was just saying that.
Good job.
Negative 10. He
Negative
just says
10.
2.5 whenever it's
That's
like,
his thing.
yeah, he'll
The
like,
answer's always 4.
Hey, Aaron, how
No.
All right.
It depends by what you mean by shrink.
Ah.
The gas will
Maybe Michael has a hypothesis.
the gas won't blow it up more.
Okay.
It'll be frozen in the same state. So if you were to stretch out the balloon, it would be the same.
Okay. All right. Michael has it.
I'm bummed that it's not gonna blow up.
I've done that with dry ice and just a regular water bottle. You leave a tiny bit of water in the bottom and put the lid on and then throw it, like off the deck out into the
I think it popped.
That was
off the deck out into the woods. It makes a loud.
Miss Dan,
Yes,
I
ma'am.
saw this video of these guys, and they took they took a thing and then they put some chemicals in it, and the chemicals were like blue, and then they poured some other chemicals in it, and it blew up and became like marshmallow stuff.
Oh yeah.
Can we do that?
Yeah, maybe. Next year's
yeah.
chemistry, so we'll do all kinds of fun things.
All
right, so-
Oxide and a Coke.
Oh, Coke and Mentos is fun.
Yes.
All right, so moving on from that diagram.
That's
Water
what-
pressure. Who can give me C under B1?
V1, C.
Yeah,
Water
I got
pressure
it.
increases as
Temperature.
depth increases.
Yeah.
The
Hey.
pressure of fluid at any given depth is constant and it is exerted equally in all directions.
There you go.
Raise your hand so-
All right, very, very good. So the weight of the Earth's atmosphere, how much does that exert at sea level?
Oh, there's temperature. Oh, that's on there.
What do we have?
101 kPa.
101. Yep.
Yeah, we wrote this.
All right. Yes.
Just like the tiny bit.
Yes.
All like deep images online are like really high pressure.
What?
I'm not following you. I'm
I
trying.
don't know.
I don't know.
What is it?
So yeah. All right. So
Is it
oh, I totally missed it. If it was, it went right over my head.
I was trying.
That's
So close.
all right. So
So close.
your air pressure is gonna decrease as your altitude increases. Okay, so who has ever been to somewhere at a high elevation, like Denver? You've been out to Arizona, right? Where have you been? You been to Denver, anywhere like that?
I've been on a plane.
Yeah, a plane. Yeah. Okay.
Denver's the best.
Where?
The only thing that ever came out.
Ear popping. Yeah, that happens.
I went to
Yeah.
Kenya.
There's some good
about
value.
ear
Kenya's like really, really.
And also-
Wait, Lily's talking, and Lily's.
Also
Hey, yo.
I used to live in the mountains, and
Right.
then this was actually with you.
Huh?
We took you to Dahlonega,
Oh,
and
yeah.
your ears popped and mine didn't, and it
Yeah.
was because I used to live up there.
Oh yeah. Okay. Wow.
Popped in Dahlonega.
Yeah.
Mine
It's not a
popped
high
sometimes.
elevation, dude.
I've had my ears pop coming down Southern Circle to get to the entrance, back entrance
Yeah,
to my
yeah, yeah.
neighborhood. Because we're getting closer and closer to the river,
We're
and you're going
all
down, down, down. So your ears can pop going up or going down. And that is, of course, because you're trying to
My
equalize.
sister's
pressure.
ears popped
Yeah.
on Stone Mountain trolley.
How do you
And
take
she
off the starts- lid with one hand and you put it back on so quickly? Like,
Oh,
you
my
have to, like, what?
chest. Sorry.
She's like,
Anyway.
She's
When
like,
you go straight
"Yeah."
down.
So-
When I was in Kenya,
Yeah,
my
you're
ears
so you
popped
have
all
like
Mhm.
I can make my
and you
ears
equalize
pop.
the pressure.
So here's what I was going to say about, yo. Hi. So here's what I was going to say about Denver, for example. So Jason does Denver a lot, or Boulder. He travels that direction a lot. And like, it's a little favorite thing of his because it's just one of life's little joys. But his contact solution, he seals it when he's up there, and then when he gets home, the bottle's all squashed because the air pressure down here is so much greater than it is way up there because the column of air pressing on us here is longer. There's more molecules than the column of air there. So when he opens it, it goes, you know, the air sucks in, and he's like, every time he's excited to do it because it's like it's the little things in life, right? Woo! But so you'll notice that if you go anywhere that's at a high elevation, or sometimes your luggage, if your luggage isn't pressurized, that'll happen. You'll see some of your stuff will explode or whatever. Always fun. So there's so we got a little graph there showing that as you got altitude increasing and pressure decreasing. All right, here's a good one. Why do a lot of athletes choose to train at high altitude?
Because it conditions them more because they have less air, so they have to learn to breathe better.
Yeah, less air or what
That's
specifically?
why Eloy Kipchoge trained in Kenya, which has a higher elevation,
Mhm.
because he went fast.
What's Chogi? What's Eloy? What is
He broke
Kipchoge,
the
it's
2-hour
a guy, he
marathon
broke the
record.
2-hour marathon, he's super fast.
Kenya's
Right.
awesome.
So
It's where he-
it's about there's less air pressure up there, so there's less. Your body runs on less oxygen because every time you inhale, the pressure of the air outside isn't as great, so your body's absorbing less and less oxygen, right? So then when you come, Cole, stop. When you come back down to sea level, your body functions much more efficiently because it has learned
It's like
to train with less oxygen. And when you get down here, it's got so much more oxygen to burn. It
It's
actually
crazy.
makes it easier.
They even
Yep.
run different. Like if you look at their feet and how they're running, a normal person when they're running who hasn't had experience running marathons picks his feet up a lot, and then like picks his feet up here and then starts.
He looks so relaxed when he runs.
He does, dude.
It looks like he's like jogging, even
It
though
looks
he's
like
running
he's-
at
it
a
looks-
13 mile per hour pace.
13
Well,
miles per hour.
There was an argument too about 10 or 15 years ago about mechanical advantage. So there was a time period when there was just like a whole ton of people from Kenya that just kept winning every race. It was like a Kenyan every time.
It's because.
And people were like, yeah, what is it? But they actually went through and they did very specific measurements of their bones in their upper and lower legs because most of them
Natural
descended
selection.
from, well, it's a tight community there. So
Yeah.
it's not like a lot of us are just, Heinz 57 mixed up. That's a pretty
Yes.
succinct genetic community. And they went through and found that some of them did have a different ratio of tibia and fibula, or it was mainly tibia to femur, sorry. And
Yeah.
it was a tiny difference, but
It's
that
just-
it did create a better mechanical advantage for moving. Like
Yeah.
Selective breeding.
that's
It's
pretty
It's
incredible.
natural selection over time.
Well, yeah, it's just not even so much natural selection because there's no need for them to run faster, but the fact that community continued to reproduce within the same confines. So those genes were continuously, dropped back into the community again and again and again, generation after generation.
Maybe it could
They
make
become
them
very
more
prevalent.
powerful.
Yeah.
Natural
There's
selection.
also a thing I heard
Yeah.
about.
Mhm.
Natural
Yeah.
selection.
No, we call that eugenics.
Eugenics.
Yeah.
Selective breeding.
Mhm.
So like
Yes.
the average person who just does an office job,
Yep.
their body can take in like 20. I forget what it's called, but
I
just say like 20 oxygen molecules. I don't know what it's called.
Mhm.
I'm just saying.
Mhm.
And then like the
Oxygen.
average like Eloy Kipchoge or something
Yeah.
can take in like
Kipchoge.
8 can take in like
Top.
80 to 100.
That's crazy.
And there's like normal people who can only take in like 20.
Yeah, that's wild. That's really, really wild.
I think
So
it's like
looking at
85.
13.2, let's talk about transmitting pressure in a fluid, okay? So transmitting pressure in a fluid. What is this principle again? This is whose principle?
Pascal's.
Pascal's principle. Okay, somebody want to tell me what it is? Want to read it?
Program language.
Pascal's principle, go ahead, Cole.
A change in pressure at any point in the fluid is transmitted equally and unchanged in all directions throughout the fluid.
Excellent. And then Ethan, why don't you give me the next one since you were going to read?
A device uses pressurized fluid acting on pistons of different sizes to change force.
Right, a hydraulic system. Okay, so there are hydraulic systems everywhere,
Hydraulic system.
right? Everywhere. All right, so if you look at the graphic there, it shows like a car lift, like a hydraulic car lift that you might see in a shop. They do use this. They do.
Yeah, I think my car
Um,
got picked up in one time.
Yeah, sometimes they do that. It's when you go into the shop and it's not on racks, it's on a lift. Now my dad uses racks, always has used racks. He's always had a preference for them. And usually they've been great.
And a pit underneath it.
Yeah, there's a pit that's big enough that you can stand in, and when you do this, your hands are under the car, like it's right above your head. But you drive up onto the rack, and it's right here. But he did have this new guy working for him, and what'd he do, Cole? What'd the new guy do?
The new guy didn't drive it on right, and the cars went.
It went right in. He didn't listen. He didn't follow directions. Dad had told him 100 times what he needed to do, and he didn't do it right, and he drove it right into the pit, and then he quit. Then he quit on the spot because he was so stressed out. I'm sure my dad was dropping every swear word on the planet at him too while his car was sitting in the pit sideways, and they had to have it winched out. And yeah, but the guy was like, "This is too stressful," and left.
That sounds like me.
That's the thing. The second time, because I remember as a kid, one of his guys dropped a Porsche in a pit. And like, of all things to drop, you're gonna drop the Porsche. In the pit.
What's on my mind? Are we allowed to do like the weekly online questions in advance?
I mean, if they're available to you. But yeah, but like you asked about the test. If it's not entered in there, you can't do it yet.
There's a video of a guy who had a pickup truck.
It'll let you know.
It was so
And it
easy.
started
bro.
falling
Your
off the
questions.
number, and the guy actually went to grab it to see if he could stop it.
Yeah, he did. He tried to grab it like that was gonna help. God bless him.
It did.
So if you look at the second diagram, it's got input force, okay? And it's showing you how it multiplies. So you've got force right there, and they've labeled it as force 1, right? And then you're pressing down on force 1, and that's a distance 1. So it's force times distance, right? So when we do that, when it goes across the bottom, you get force 1 and distance 1 becomes force 2 and distance 2. And then it comes up the other side, and now you get a second pressure, and that's force 2, area 2. We're not going to get too super specific about that because that becomes like straight up physics.
Could you
But
explain to me like I'm 5?
yeah, look at the diagram.
Did you not?
There you go. So there you go.
So you
All right.
get down on one thing and everything comes out.
Right. So that's how hydraulic systems work. Now another hydraulic system, who remembers way back, who was with me when we did biology? Way back. Do you remember how sea stars move?
It's a pretty long relationship.
Do you remember what they use?
You know?
What they use? What are we talking about?
Sea stars.
I remember we
Yeah, I remember.
They
that.
use the suction thing.
They do use suction. So they have what's called, if you remember, a water vascular system. Do you remember that?
No.
And it's actually a natural hydraulic system.
Well,
They move the water within this, it's a tubular system within their bodies, and they use little tiny muscles because it's like, it's the little tubes have like little sacs on them, and they use muscles to squeeze or release, and it causes the water to push from one end to
Is it
another.
like one of those
Y'all always going there.
Is it like those boat controls that they can do with the jets on the sides?
Yeah, similar. And that's how, but they don't move like you're thinking more like a squid. A squid will bring water into its body and contract its body, and
Like a
it
jet ski, because
shoots.
it doesn't have a propeller, it's a jet.
Right. So, but they use this to like move a leg and operate a suction cup. That's how they work. So there's hydraulic systems in nature, and then there's hydraulic systems, that we create. Like, where do you see them every day driving around? Where do you see hydraulic systems?
I don't know.
Cars
Construction?
have them.
Construction
Car
site,
suspension.
cars, yes, suspension. How about brakes? How does that little tiny pedal in your mom or dad's foot stop your Buster
I know,
van or your Buster
know.
bus or your bus?
I know.
Yeah, yeah.
I know. It's
How's it work?
because we had it fixed on twice.
Yeah, you have.
What do you call it?
It's a rubber padding on the.
Wait a minute. Michael, stop. Wait a minute.
It's two rubber pieces that clamp down on a piece of metal.
That's a brake pad. Right. How does it?
It's a hydraulic system.
Yep,
So
it's a
pushes-
hydraulic
pushes
system.
it.
Correct. So, or
but-
fluid. Yeah.
Except
Sometimes it's
when
over fluid.
when it's adjusted wrong and the metal goes on metal instead of rubber on metal, and then it smells bad.
Yeah, that's not great. There's your
That
brake
was fun.
pads
Yeah.
worn down.
No, they just didn't put it on.
So anyway.
They just put it on quicker.
All right, so here's a challenge for somebody. All right, now I'm hoping this is gonna work. I hope this has no holes in
It's the
it.
same as the.
Oh, I remember this. I haven't done this since like first grade.
All right,
really
Yeah,
good.
all right. Who wants to be my guinea pig?
Aaron.
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 You can fill this like it's a balloon.
I swear to
Fill it up as quickly as you can.
It's
Going?
going.
No, it's
Working
not.
on it.
That's my pencil.
It literally isn't.
It
Well,
literally
I-
I stole it from me.
You didn't
We
take it
got
back
this,
within an
Aaron.
hour of me taking
Move
it,
on.
which means it's now mine.
He's
That's not how
Mullen.
that works.
Yeah, me sure I can do it.
Oh, Danny's trying.
Dude, every time you look up, you letting the
He's
air
gonna
out.
pass out.
Don't cover up your nose.
Sydney, what that
You're
is for?
stupid. You're so.
That's
Hold it further
breathe in
away.
through your
Blow.
nose, breathe out through your
Just
mouth.
blow.
Oh my god.
Look, Miss Danny's doing it right.
See, you have to hold it away.
You're letting the air out.
Oh, geez.
Oh, we did
look
it.
at that.
You guys stop it.
Hey,
Now close the end up.
Danny stubby nose.
what did I do differently?
You hold it away.
You did it right.
I held it away. Why? What are we doing? Thank you. Don't know?
That's really bad fun.
Oh my gosh, did you
Oh.
I don't need
Henry,
it.
hold it out. Hold it
Oh,
out.
Nancy, you did it.
Okay, hold it open real big, Sydney. Hold it open big. And now, don't put it on your mouth. Hold it a couple inches from your face. Now blow.
I'll fold the computer down. We're gonna knock it off.
There you go. One more good blow. And Sydney's got it.
Wait, is the computer recording again?
Yes, but it's looking over here.
Oh my god. I said it.
It's not looking at you. It's
I
looking
know,
over
but I
here.
said it bad. I said it was a joke, and I might have heard it.
I don't know.
Can you
So what do we got?
it out?
I don't know. What have we got? All right.
Give me the two. My two.
So careful.
Henry, are you dating the balloon?
All right. So
It is Henry's
all
pet.
right. Let me see them both.
Oh my god. Michael Boxer, I swear. I swear. You did it on purpose.
All right. So now go ahead and flatten it out.
You can't.
Oh, I'll take it. Here.
Aaron, what are you doing?
I don't.
Every time we think it's fun.
Oh, they tied it. They tied it.
I'll help you.
They tied it.
So these are actually for anybody who has younger siblings or whatever.
Oh, yeah.
These are those diaper genies. That's
How much do you
because that's what works because it's a nice long bag.
What?
So
Diaper genie?
yeah, 'cause that's
You're
what
like
works.
those diaper fiends?
Wait, how much do you
Alright, so
That is your diaper.
Jesus, what kind of craps is he taking?
all right, so no. So the way those work, if you've ever seen one of those, so the way those work is it's a long tubular bag like that, and it comes in a roll like a sock. You know, when you roll a sock down, it comes like that. And the idea is that you stuff the diaper down into the machine, and then you turn, and it rotates that. And then there's another section of bag. So when you're done, it's like a sausage full of diapers, but each one is encapsulated like a Lynx, you know, like sausage links. But each one is encapsulated in a bag. But they're great. Yeah, but they're great big long bags. So what did we just demonstrate? A particular principle. Whose principle is it?
Bernoulli's.
Bernoulli's principle. Okay. According to Bernoulli's principle, as the speed of fluid increases, the pressure within the fluid decreases. So when Aaron had his mouth up there and was huffing away on the thing, why was it easier to blow it from further away versus right up? What was the difference? You guys are just so terrible. You think my middle schoolers would be the giggly ones for the show.
Oh, we watched
They don't know
enough
it.
of that.
Oh, they know.
Oh, it'll be a matter of time before they'll just jerk
I
off.
still haven't gotten the stock yet, but I still.
Okay.
That is
So-
great. 200 each.
So why did it work?
My-
Oh, yeah, there's a little something.
Kill it, Danny.
Eat it.
Kill it.
No, I already named it.
It looks like a cockroach.
Okay.
Can you go potty real quick?
Her name's Angelica.
Oh, that's
It's her name, Angela.
Eat it.
Is your friend Don't spit on Angelica.
There was mist that came out.
Aaron used water.
There's a kid
water.
who used to gymnastics and he's like smacked it in the hands and he ate it.
What is that?
Kill it.
Just run
It's like a roach. That's my
It's dead.
It's not dead.
Is it Aaron?
If it wasn't dead before, it's definitely dead now.
Alive.
Yeah, I did.
He's still alive, Mr. I think his.
I'm on
Most bugs I just let out, but not these.
I'm on 3.
Yeah.
Alright, so
That's how you
somebody, y'all, somebody
Wait.
explain why did it work? Second,
Yeah, I
second
did.
way, but not the first way.
And
What?
then
Yeah,
we were both
exactly.
laughing. And just Andy was behind me.
Somebody explain why it works the second way, but not the first way. Hold on to that. Why did it work better?
I
The
don't
second
Yeah,
way.
because you're
Because Aaron.
letting air in when you do that while it's rolling.
It's part of it. Look at it in terms of Bernoulli's principle and tell me why it worked.
Thanks, Mr. Bernoulli. The Bernoulli printed poll will make it.
What do we think? So it says Bernoulli's principle, as the speed of a fluid increases, the pressure within the fluid decreases. Which do you think was faster speed?
Me.
Aaron was huffing away with faster speed. So your pressure had decreased, yes?
Yeah.
So when the pressure decreased, it was much harder for him to fill that whole bag, right? But when Sydney blew on it from a couple inches back, that air is moving along more slowly, right? And it picked up more pressure, it filled up the bag. So somebody explain to me how Bernoulli's principle is essential for flight.
All right, how do you
Because
say?
we
Just
jump.
get out of the way. Is it Bernoulli,
Bernoulli. So how is Bernoulli's principle essential for flight? Who can explain it? Who understands how it works?
I'm thinking.
All right, so you're riding. Wait a minute, you're riding in your car. Wait, shush. You're riding in your car, okay? You put your hand out the window like this, all right?
And it falls off.
Yeah.
And then you put your hand, then you do this. What happens?
I've never been
It, like it's more aerodynamic.
Yeah. So here's how it works. Mhm.
Show us. Wait, are you gonna take us for a ride in your
No.
Mustang?
No.
I don't think
You people don't deserve the
any of us.
Okay.
I can drive the Mustang.
So.
I know you can.
You
can drive into a wall.
Let's pretend we're looking at a plane and we just is never gonna fly again, so we don't have to worry about this being an issue. But we cut its wing in half. All right,
So wait,
If
like
you-
this way or this way?
Perspective.
that way.
Okay.
So in
Okay.
like shot.
the engine would fall.
The wing is shaped like this. Okay.
Just a left.
And that's a
I
cross section, right?
Yeah, this is a cross section. Very good. All right. Yeah. So the wing is shaped like this. So here comes the air. All right. And the air's coming at it. Right.
Yes.
Where's it gonna go? It's gonna go
Up,
one
up.
of two ways.
Up or down.
Right?
Up and down.
It can go this way, or it can go this way.
Because when it goes
All
down,
right.
it shoots
Which
the air down,
one
giving it
has-
lift, and it goes up.
Wait a minute. Which one has greater distance to cover? The air below or the air above?
There above.
The air above has greater distance. Okay. Is it the same volume of air though?
No.
Yes.
Yeah. No. It's. I guess. Yeah.
It's the same volume of air, but now this volume has to spread out over more distance. Okay?
Who wrote it was
So-
the top right of the best whiteboard?
Me.
No, I did.
So,
Who did?
are you listening? What?
Nothing.
Anyway.
Mama.
Mama.
It says who.
Mom, there's nothing.
Hi. So look.
Yeah, stop thing.
So look at this. When it gets here, this is the same volume of air. Okay? This volume of air has to spread out over a larger distance than this volume of air. So which section of air is going to have higher pressure?
Yes.
Say again.
Think about it. This is the same volume of air. The air is being divided, right? This air on top has to cover more distance than this air on the bottom in the same amount of time. So which one is going to be more dense? The air
The top
below
one.
or the air above?
Air below.
The air below. Why?
Because it has like more pressure.
Yeah. So say you've got, hang on. Say you have, let's just pretend for argument's sake that we have these 8 Oh man, can't see them. But yeah, you can. These 8 air, let's say these are just random molecules, okay? All right,
We're a special random molecule.
All right. units of air.
Pick it up.
These 4 are going down here, and they'll be nice and evenly spread. All right.
Oh, that's
These 4 are going up here. Can they be as evenly spread? They're much further apart. This distance, right? So because of this chunk of air down here is going to have greater pressure, right? And it's going to push it which direction? Which way is the wing going to go? Which way is the wind? Which way is the wing going to go? What's going to happen?
Up.
It goes up. Okay.
That one
Right.
pushes.
Because
That one-
this is yes, the air's pushing up.
Yeah.
So
Sorry.
it goes up, and when it goes up, we call that what? Birds' wings are the same shape, exactly the same shape.
That's why planes have
What about Uber?
flaps.
Bird?
What about Eber?
What about Uber? Oh.
Oh, Lyft, Uber. I got it. Sorry, I was like, did you say Uber? Yeah. Anyway, so yeah, this is Lyft, and Lyft is possible due to Bernoulli's principle. So you have this graphic in your notes. Do you see the graphic of the wing? Mm-hmm. And it says it has low pressure and high velocity. It's got to go faster. And the bottom one says high pressure, low velocity. There's a shorter distance on the bottom. All right, so lift is an upward force created by the difference between low pressure on top of a wing and high pressure beneath the wing. Henry, sit down, please. I'm not quite sure what's going on. Okay, and if you look at the bottom, we've got an atomizer. Does everybody see the atomizer at the bottom of the last page notes? Do you see the atomizer?
What's an atomizer?
Oh, I see it.
It's a type
yeah.
of spray bottle.
Yeah, it turns people into atoms.
No,
Oh,
so
yeah.
Perfume old stuff.
yeah, it's like an old school perfume bottle. All right, so they're called atomizers, although they really don't turn the liquid into atoms, but they do turn it into tiny, tiny, tiny little particles.
A-D-A-M or A-T-O?
ATOM, atomizer.
A-D-A-M.
So you got a little bottle, okay? You got a little bottle, and off the back of this bottle, you've got this, usually like this, a big, like one of those, you know when they pump up your, when you get your blood pressure done and they squeeze that bulb? That's exactly the same kind of thing. And then you've got this little tube that goes down into the bottle, and then there's usually like little fancy looking bottles, sometimes they're all fancy and they're sparkly glass and whatever.
A sticker or something.
Right? Okay. So when you put pressure on this, when you put pressure on this, it causes the air in here to blow this direction. And when it does that, this fast moving air is going to have lower pressure, right?
So it sucks up the air from
It sucks up the liquid. There's usually a liquid in here, yes. It sucks the liquid up, right? And then what happens is you end up with this, the liquid goes up and it joins the air, and then what you get is like a little poof. It's a spray. If you've ever sprayed your lawn, who has ever sprayed their lawn with like weed killer that you hook to the hose?
Yeah.
You ever done that? Same thing, except not air, it's water. You put the hose here, it pushes water across the top. No, it's fluid, but it's the same Bernoulli's principle. So in the case of one of
You
those,
spray a spray bottle or like a water gun.
that's
but it
the
doesn't-
same thing
No,
too.
but it doesn't pick up all the water, so it's like it only squirts a little bit, and the rest is all air.
Yeah, well, it could be the same thing. But if you ever done one of those bottles that you tie to the hose, sometimes it's herbicide or fertilizer or bug repellent, but you hook it on and you spray.
We can't do that anymore because Traveler's gonna die if we do it.
Oh my gosh.
literally.
Same thing, like the water forces, it comes across the top really hard, really fast, lots of pressure, and it sucks, basically, it decreases the pressure here, increase down here, the water that you're using, or the fertilizer, or the Miracle-Gro, or the whatever, and it comes flying out this end as a mixture of water and whatever you're using, fertilizer, or herbicide, or we did some herbicide in the back. We tried to get rid of all of the weeds by spraying that major weed killer, but it's the same thing. You hook it to the hose and you, so that's Bernoulli's principle. All right, so you had some questions. Let me see how y'all did. So I'm just gonna see how you did for answers. So how about the amount of water pressure your body experiences while swimming? Is it affected by your body fat and your buoyancy, the volume of the water in the pool, or how deep you are in the pool? Correct. So
I did not understand that question.
I know that's why I was going over this one, because apparently some people thought they were all answers. So I was like, no, they're not all answers. There you go. It does. That was the next thing I was going to say. You swim to the bottom of a pool, it can really seriously make your ears hurt because the pressure's greater. So this is why you can swim. This is also why it doesn't matter if you're swimming in the center of the ocean over the deepest part of the planet, or if you're, swimming in a 6-foot deep pool, you're still affected the same way by the water pressure above or below you. So
Well,
if you
that's
go
not true.
down,
It could be a little different because there's nutrients that are different in the.
yeah,
But you
but
won't be able to.
minorly, yeah. So who can give me some example? Actually, everybody, we'll go around. Everybody give me an example of a hydraulic
I'll go
system
first.
you've seen,
I can't
and you
get
can't
one.
use an example anybody else used. Okay,
okay.
Michael wants to go first.
It's the dump truck.
Dump truck, all right. Wait a minute.
A crane.
A crane, yeah, those are cool. All right.
Those are
Forklift, who else has one?
A ladder on a fire
Hydraulic
truck.
brake systems.
Brake system, yep. Ladder on a fire truck. 3 more. Hydraulic lifts, okay. Elevators, sometimes they are.
Yo.
Sometimes they're cables and pulleys and things, yeah.
Other times
Right,
they're
That's
sometimes.
what trains usually are.
Yeah, sometimes they are too. Mhm. How about it, Ethan? We're waiting on you.
A brake system in a car.
Ah, she already said it.
Come on, Ethan.
Yeah, well, what a bot, dude. Brakes on a bike.
No,
Yeah, what he said,
no,
brakes on the
no,
bike.
they're not hydraulic.
Hydraulic lift. No, lift. He can't use that. It's got to be a lift system. Hydraulic lift.
You know what this brakes? It's still a cable.
No.
Okay, have you seen?
You said it.
What'd you say?
C-Star? Like,
Yeah, okay, that works. They can lift. All right. So has anybody ever seen one of those cars in Napoleon Dynamite? Pedro's cousins drove one that has the hydraulics.
Those are so cool.
Yeah, it has a hydraulic suspension. Goes, the car can lift up and go down. Right,
And
that's
this big
totally.
boy, he does it.
All right. And can somebody explain to me what characteristics fluids share?
They all fit to the size of the container.
Right. Very
That's the
good.
only thing that share.
What's different between them?
Oh, well, what's different? Well, that's not what you said. That's not what the question
Eh, that's right. I'm asking a second
Okay.
question. How about
But the question
liquids
isn't
and
right.
gases? What's the
question
difference?
isn't right because you put an S
One
in
thing I know.
characteristics and it's no, it's not funny.
Yeah, I missed that one. Should be. There you go.
It's not funny.
There we go.
Didn't laugh.
no funny didn't laugh.
They don't share in common. They have different volume.
The
A
volume.
liquid has a fixed volume and a fixed and
Yeah,
a free
it's fine.
surface.
You got it.
While
Good.
the other ones have a fixed surface and a non.
Very good. Henry, give me an example of a hydraulic lift system.
Oh, what?
Hydraulic lift system.
Oh, like a crane or something?
I already
Yes,
said
you
that.
said that one. Can you think of a different one?
No, like brakes on a car.
She said that
Said
one.
that one.
That's a good one. See how many he can go through that Jill already said.
How about I don't?
Okay. All right. That's good.
Wow. Okay.
All right. So
Rude.
I wanted to in the last little bit here. Let's see. Did anybody have trouble with anything over break? Any of the assignments over break?
I got an
Did we
A.
figured it out? I have not. Like I said, I haven't graded any of it yet. I got to go back through it all. I will.
I had a problem with it.
Did you say ooh?
Read the board, guys. Mama Ulu, okay?
Oh, there it is.
Yes, it says
Uwu.
Mama Ulu.
I didn't see the uwu was behind.
There's nothing wrong with Ulu.
There's
Yes,
everything.
there is.
Mama.
Everything.
There's nothing wrong with the song that says uwu because it's not uwu.
That's
The
not
word
uwu.
uwu is just like
That's how Freddie
cringy and
Mercury
big
spelled it.
needy.
Wouldn't
Sit
be
on
O.
the mom basement and all just watch anime. That's what uwu means. But the Bohemian
All right.
Rhapsody.
Okay, so then what I wanted to show you guys, I wanted to show you guys the videos that we got from our trip, because I wanted to show y'all in particular the drone footage that Jason got. He got some.
There's any beach right there.
There was some beach, but we not that. Wait a minute, hold on. And then the test this week. Let me make sure there's nothing on there that you need. You take that off.
Yeah, right down. Ethan, I need my pen. Here, have your pencil back. I need my pen.
No.
It's a trade
Y'all are
system.
nuts.
No, I
I want to make sure that
Yeah,
there's
it's
nothing on
feedback.
this upcoming test
Oh,
that'll throw y'all
okay.
off.
You
It
think.
is, but wait a minute. 1 second. Ooh, woo, woo. What are you doing?
Michael just almost toasted her back.
Are you all
Are you
right
okay,
there,
Michael?
Hey, you're bending the floor.
Wait, a toaster bath would kill you.
How am I bending
Yeah,
the
exactly,
floor?
you
I'm
almost
not
like-
that bad.
No, I'm done. with the heck out of it.
Ooh.
What is that?
The elevator.
Ooh, woo. All right, let me look real quick at this week's test. 12.
Wait, I already did it.
Oh my.
No, you didn't.
I didn't. I thought I did
Oh wait,
all of
wrong
them.
class. This is not you guys. This is the little people.
The little ones.
Excuse you?
The little ones.
You would know.
Okay.
Michael, that's not
I
funny.
was trying to.
All right, test 12. Oh yeah, you did do it, Henry. Okay, test
I
12.
Take offense to that. To be
Wait, what did
honest.
he do? Wait, what did
That's it.
He insulted the size.
All right, so here comes some questions.
Michael insulted.
Are you listening?
I insulted Ethan.
Are y'all listening?
Hey.
Whoops, hold on. I just hit the wrong thing again. All right. So let's see. Here we go. You will need to know the result of force distributed over area. Y'all paying attention?
I don't need to.
You will need to know the unit for pressure. And you will need to know the characteristics of fluids. And which states of matter can be considered fluids. Okay.
That's nice.
And let's see, you will need to know about pressure as it relates to water and depth. Now remember, when you are standing on the surface of the earth, you are experiencing the pressure of the column of air above you. When you're in the water, you're experiencing the air and the water
Because you're
above
pushing,
you.
it's like if you put your hand in a thing and the water pushes up.
Yeah.
Um, it's
Displacement.
yeah, it's displacement because you're displacing the entire ocean.
Yeah.
You're not just
yeah.
displacing
Yep.
the thing above.
Everything.
Does
Yeah.
that mean the reason for beaches rising is the boats in the water? Like,
Oh my gosh.
We have
partnerships and friendships. They're
That's
very long
so
boats.
negligible. Okay.
No,
It's not global warming, it's boats.
All right.
You sound like Donald Trump.
You need to know. You need to know the relationship between air pressure and altitude.
Oh my gosh, that's what it is. Boat.
You need to know about Newton's law of fluids. Got that? Got Newton's law of fluids?
Yes.
Okay, and you'll need to know about Bernoulli's principle, what it states, and lastly, there are 9 questions, and you're going to need to be able to explain lift. And be sure you explain it in terms of Bernoulli's principle. Don't be all like, yeah, wings make planes fly, or the air pushes it up. No, be able to explain to me exactly how this works, right?
Oh, okay.
Okay? All right.
Okay.
So what I'll do now is, I think I can put them on the TV.
Go and turn it on.
Oh.
Yeah, go get YouTube up Dad's channel. So we got he's got 2 different, hang on. He's got two different videos that he made. He did one at Isle of Mull, which was the place we stayed when we left Edinburgh. And he did the other at Clahane, which is near Liscannor in Ireland. The one in Isle of Mull in Scotland is the one I sent you all pictures of and said, hey, if you did earth science last year, look at these rocks. I was just so amazed. They're all, when you look at rock layers, they're typically horizontal, but so many of these were tipped vertically.
Yes.
So, oh boy, there we go. All right, so if y'all want to set your table up for Spanish, let me hand some things back to you first too. Set your table up for Spanish.
Rude.
And
Duolingo.
I will
Duolingo sucks.
I just like.
Yeah,
That bird is up to you.
Hang on, because I'm handing stuff back. So don't close your binders until you have everything.
You're
Huh?
making fun of me today.
Yes.
I was making fun of you.
During your team, what?
It's hilarious.
Yeah.
No, yeah, just stop reacting now.
Oh, okay. Okay, okay. Okay, that's fine. That's how labs work. Okay.
Oh,
that's
when
fine.
you walk. Yeah, I can't.
Okay, that's fine. That's absolutely fine. I'll remember that when I'm looking over them. Oop, I think that's you. Right. Right. Okay. I'll be sure that I look at that when if I don't remember it, tell me. If I give you some weird comment or whatever, it's because
Yeah,
that's it for me. So if you guys want to go sit in there, wait to start it, Cole. Do Oban first.
The only